So the work is going to look very similar, both of these. What is the main difference with these two questions? Oh yeah, okay. To work the problems out, standard deviation is going to change in one of them. The big difference is here I'm picking one person. Why am I still allowed to do the problem? 1 is not bigger than 30. Right? So why am I still allowed to do part A? Why am I still allowed to look up a probability for part A? Because I tell you it's normal. I don't need the sample size to save my ass. I already know it's normal. You guys understand? So if it starts off normal, how large of a sample do I need to make it normal? 1. I mean, I don't need anything to save me. It's already normally distributed. But if I do pick a sample of 16, what's going to change? Standard deviation. So here, it's 16. Is that bigger than 30? No. Same. They already told me it's normal. I can have any sample size I want to now. The earlier problem, why did I need it to be greater than 30? Because the problem didn't say it was normal. I didn't know what kind of distribution it was. I have to be safe and make sure the sample's at least, bigger than 30. So what goes in the middle here? 35. That's the mean. 37 is what I'm interested in. Greater to be exact. And I change that into what? Z-score? What do I put on the bottom? 3.17. Because that's the one that works for individuals, and I am talking about an individual student. I like it. So there you get 0.62. I don't know. 0.63. And now I look it up, right? I got a z-score now. I look it up. I can put it underneath here for 1, 2. I look it up. I get this area. And, of course, then I have to adjust it to be the other side.
7357.
So over here you get 7357. So over here you're going to get it's about a 26% chance to get randomly pick one first grader who's taller than 37 inches, right? I like it. To be the boss. So the only thing, all the work's going to look exactly the same for this part. The only thing that changes, the very first thing I do is change standard deviation. So the new one is going to be the old one divided by what? Divided by square root of 16. I love the random shit people put in here. You have it on you will have it on your formula sheet. You know what n means. N is the number of things you're working with, right? So 16 goes down here, and the top has got to be the old standard deviation. So sometimes I'll call this the new standard deviation. It really isn't. It's a standard deviation for groups instead of individuals. So this will be a standard deviation for groups of 16. I'll spread out our groups of 16 from each other. And what do you get there? 7925. Ooh, bless you. So you round it to 3 places, be 0.79 something. I don't know what was after that. 25. Was it 25 or 2? It doesn't matter. Let's use this. So now I make the z-score the same way. It's just going to be divided by that. So that's going to be 2.52, I think. 2.52. And then so now it's much further away than it was because everything shifted to the middle. To be honest, I don't make you do this, but this should be a lot skinnier. But all you need is a normal just so you can kind of put stuff on there as anchors. But to be honest, again, everything shifted to the middle. Now my step size has gotten much smaller, which is why that same score is so much further away. because my steps have gotten smaller. When I look up 2.52, what do you guys get? 9941? So this only leaves how much up there? Yeah. So just a little more than 0.5% chance now that you'll get 16 first graders whose average height is more than 30. That makes sense. If I take a group of 16 first graders, their average height should be close to 35. And of course, what measures closeness is the standard deviation, right? This is the number standard deviation. The standard deviation size changed, so what close is now different, right? So up here, this was decently close. It was not even a full step away, but now it's 2.5 steps away. Holy shit. Maybe. You gotta appreciate this. That it's one little change. How do you know when to make the change? What do you look for to know when to do this? What told me to do this? There was a sample taken, and I asked you about the mean, the sample mean. Those two things have to happen. If those two things happen, you change the standard deviation. I like some of you guys like, sure. Sounds good. All right, let me make you do another one on your own here. Here we go. Oh shit, this will be the last thing we do. Ever. No.
Jeff, where did the 0059 come from?
You subtract
The opposite of this.
Oh, that.
Yeah. Yep. So given an average test grade of 76 and a standard deviation of 14.91, take a sample of 78 tests. What's the probability that the sample mean for the 78 is less than 75.4? Do it. why can I can get a lot of smart ass answers. Why can I draw a picture for this problem? Yeah, sample size is 78, bigger than 30. I know it's normal enough, which pretty accurately describes my drawings. Normal enough. What goes right in the middle?
78. Or 76.
76. And I'm interested in 75.4, right? Less than that. Okay. So the very first thing, even before you drew the picture, you could do was the very first thing. Because what is it that's happening here? Asking about the sample mean. And I took a sample. Therefore, what's got to change? Standard deviation. And what stays the same? The mean. Mean doesn't give a shit if you take one person at a time or two people at a time. I can't suddenly change the average age of the room by taking 3 of you at a time. And then take 15 of you and everybody's babies. I don't know what the shit that, it's freaky, right? So, standard deviation now is the old one divided by the square root of 78. Love it.
1.688.
1.688? And now you just do the same old, that's beautiful, you gotta love that. As far as messing up the procedure, it doesn't really do much. It does this one little thing. And you have the trigger now about when to do it. What's really funny is if I take a sample of 1, n is 1, which means it would stay the same. Isn't that beautiful? So the formula actually works for the extreme situation. So now I can do a z-score. Should go sing some blues after this or something. With the right kind of voice. Maybe some Bryan Adams. Remember Bryan Adams? Nope.
That's not
I'm talking about where my voice is now. So my head started going to some people like, everywhere you go.
No.
Yes.
Maybe that's why.
I'm not going to do that to you. You would quickly see why I don't sing for a living. What is it? Sorry? 0.36. And if you look that up, yeah, B594, I like it. And that, thankfully, is the area of what I asked for, so that's the answer. So about almost a 36% chance that any random group of 78 tests would have an average less than 75.4. Crazy. Okay, so you've all got the practice test, right? So I'm going to have the answer key for that next time. And number 4 is a problem that's very similar to what we just did. Number 4 is a problem. It's very similar to what we just did. Okay.